is a beautiful question. I've already done this question using the chord method, but in this question I would be utilizing the method suggested by one of our viewers. I have given the credits to the viewer in the description. You can check his name out. Now we have got a circle, and the circle is present inside a triangle, and the circle is actually tangential to the triangle. So let me draw that. So that is looking fine, and there is also a tangent over here. Now okay, now we are expected to find the area of ADE. So I'm taking this point as A, B, C. There is a 90 degree there, and this point of contact is taken as D, and there is a point of contact is taken as E, and the point of contact is taken as F. Now from D we have a line that is hitting E, and from E we got a line hitting F, right? So this is how the figure is given. Now we are expected to find ADE, and we've been given this distance AC, and that distance AC is 4 units. This is also given. BC is equal to 3 units, and AB is equal to 5 units, and the area of the triangle, not the circle, it's the area of the triangle is given to be as 6 units. Now with all of this we have to obtain the area of this triangle, area of ADE. Now foremost, what I wish to do is I would want to find out the radius. Now you may be wondering why I need to find the radius. If I know the radius, then the problem is simple, and within a minute you will know what I am really talking about, right? So what I wish to do is I would like to drop a line to the center O, and then I will complete the triangle here. So the triangle is completed. Now from the center O I am dropping a line to the point D. Now when you draw a line from O to the tangent, then that would make an angle of 90 degrees by the tangent theorem. Let me reiterate, if you were to draw a line from O to the tangent, then the angle between the line and the tangent is 90 degrees. This is tangent theorem. And similarly, what I will do, I will drop a line from O to the tangent. So this is going to be making an angle of 90 degrees. So there is a 90 degree made here by the line with the tangent. Right? Fair enough. Now, having drawn that, let me also complete this end of the triangle. So I got triangle over here, triangle over here, triangle over here. Now, clearly you can see that FCD, they're all making 90 degrees. So clearly there will also be a 90 degree over here. So that would mean we are looking at a square. So clearly DCFO is a square. So that means all sides are equal. Now, since OD is equal to OF, which is equal to the radius R, now what I wish to do is, I would also like to drop a line from O to E, right? So if I were to drop a line from O to E, okay, so you can visualize a line because of the absence of right equipment. If I were to drop a line from O, it would look a little bit chaotic. So just have in mind that this distance from O to E, is going to be R, from O to D is R, from O to F is R, this is R, this is R. So all of these sides are equal, so they form a square. Now we may not be utilizing this concept, but we will, or I should say we will not be utilizing the concept of the square much, but all we need is to find the radius R. Now clearly you can see that this is triangle T1, I'm taking this as T2 and I'm taking this as T3. So area of triangle ACB is equal to area of T1 plus area of T2 plus area of T3, right? Now we know the area of ACB is 6 units and area of T1 is half times base into height. Base into height. So this is the formula that I would be utilizing. So if I were to utilize this formula, area of T1 is half times, my base is given to be as 4 units and my height is R units, plus half times T2. My base, this entire base is BC is given to be as 3 units and the height is R units, plus 1 over 2 times the base for this is 5 units and R. So I can take 1 over 2 out, R out. This is going to give me 4 plus 3 plus 5. 7 plus 5, 12. So I get 12 times R divided by 2, which is nothing but 6 times R. I get a 6 here. Therefore R is equal to 6 divided by 6 is equal to 1. R is equal to 1 unit. Right? Okay, so R is equal to 1 unit here. And 1 unit here. 1 unit here, 1 unit here. Now this entire length is 4 units. So if this is 1 unit, right, this is 1 unit. As I mentioned to you, this entire length is 4 units. If this part, if DC is 1 unit, let me write that down. If DC is equal to 1, this implies what will be AD? AD will be equal to 3 units, right? So this is going to be 3. Now from two tangent theorem, if you were to draw two tangents from an external point, then the tangents drawn will be of equal length. In other words, if you were to draw a tangent from a point outside of the circle, and the tangents drawn, in this case that we've got two tangents, and they would be of equal length. So that would mean this will be of the same length. This will be equal to this, right? So I can just place 3 here. So how am I getting those 3 units here? Because of the two tangent theorem. If you were to draw two tangents from a point outside of the circle, then the length of the tangents will be equal, and that's why I have 3 units here. Now this entire angle is A, right? Now this is 90 degree. Now let me just take this as some theta, right? Now area, this is clearly an isosceles triangle. Two sides are equal. Clearly ADE is an isosceles triangle, right? So that would mean the area is going to be half times A into B into sine theta. Now if you're taking the same sides, this is 3 units, this is 3 units. If you're taking the same sides, then you need to take the angle between the two sides into consideration, right? You need to take this angle into consideration. Have that in mind. In the previous problem, I have used the length of the chord and obtained the length of the side, and subsequently I evaluated ADE. But in this case, I am just using two tangent theorem, and then I am applying the formula for isosceles triangle. Now, so in this case, A is equal to 3 units and B is equal to 3 units. So sine theta would be the angle between these two sides. Now this is 90 degree. Watch here, this is 90 degree. So I'm using this space here. So therefore, sine theta is equal to opposite side divided by hypotenuse. Hypotenuse side. So what is on the opposite side? Opposite side is BC. What is BC? 3 units. And what is hypotenuse side? 5 units. So I'm going to take sine theta is equal to 3 over 5 over here. So let me use this space. So therefore area is equal to half times 3 into 3, because these two sides are taken, and then sine theta is 3 divided by 5. 3 3s are 9, 9 3s are 27. 5 into 2 is 10, which is equal to 2.7 square units. So what is this? This is the area of ADE. So I have done this question in 2 different ways, and you can check them out, right? This is a much shorter way, and the previous one is a little bit lengthier. Thank you everybody. Enjoy your day.